Hello, welcome to Math 1330, Section 3.5. This is called the Lien-Teef model. You have two possibilities for this model, an open model and a closed model. Okay, so let me kind of explain where this is used. This is used for, this is used when you have, so like, for like production. So say that you're producing, and agriculture is what comes to mind, mostly because, I know Lubbock is a town, but it's also a cotton town. So it's big for, the Lubbock area is actually one of the world's top producers. Around the Lubbock area is where 5% of the world's cotton is produced. And so it's a big agriculture area around Lubbock. And so what you have in the open model is where you talk about where you're taking in production and you're talking about crops going out to the market. And so you take in all the production and everything going out to the market, and you take in all that revenue, and you worry about and you consider how much goes out to the market. Whereas in a closed model, you're only talking about what is used within the farm. Okay, so everything gets put back into the farm, nothing ever goes back out. Okay, so that's the difference between a closed model and an open model. So in a closed model, everything is used within the farm. Nothing ever goes out. Everything is used within the farm. Whereas in an open model, stuff goes out of the farm. And you can say, well, how everything's an open model? Well, not everything is an open model. You do have, if you look at there are some farms that just solely produce for within their household. My husband and I have a farm that is 1/5 of an acre that we just produce within our household. So everything that we have, nothing ever goes out of our household. And so all of our materials and stuff is within our household. We never sell anything. So that would be a closed model, that everything is within the household. Okay. I will say this, that for the common finals, this section has been on the last few tests. Now, if you look at the textbook says to always do this using inverses. Now, that is section 3.4. I did not cover 3.4 because half of the homework questions in this, you have to go back and use 3.3, not 3.4. But they tell you to solve the questions using 3.4, so you have to solve them using 3.4, and then you have to do them again using 3.3. So you have to solve them twice. So what I decided is that, you know what, I'm just going to teach you how to do it using 3.3, because every question can be solved using 3.3. So I'm only doing it one method instead of the way the textbook has you doing it twice. Okay, so I'm only doing it one way. So if you're looking at how to do it on the videos through the textbook, or if you're seeing the watch its in the homework, they're going to show you a different method. Okay, and so when I send out the link that says, hey, the videos are up, I'm going to tell you I'm doing it a different way. Okay, my method is to have you do it only one way. All right, and so in all the examples that I'm working here and I'm scrolling through here are open models, are open models because 75% of the homework and 75% of what you see in the real world are open models. Okay, now the next thing I'm going to say is that 95% of the mistakes that people make when they work these homework questions is they forget to do this first step right here. They forget to take the identity matrix, which is 1, 0, 0, 1, and subtract it. So they forget this step right here. Okay? So please don't forget this step. Okay? And this formula is not given to you on the final. All right? I only give you what is given to you on the final for the common final. That is part of that I'm restricted to for either the OnLive or the live. So here's the other thing. Don't forget to tell me what X and Y are. Okay? So the other thing that helps is to write out in words this part. The sales to service and service to sales and sales to sales and service to service. Okay? I know it doesn't make sense, but it helps you make up the matrix. Okay? So, let's get started. And I know it's going to sound weird, I'm actually going to start with example 2. Because example 2 and example 3, the matrix is already given to you. All right? Which is 90% of the questions that have been given on the final. Example 1 is the hardest one. So I'm going to start with the easier examples and then come back to the hardest example. And I just oops when I made my notes 4 or 5 years ago because I just wasn't thinking and I picked the hardest one first. I think I was going to only do one example and then I realized that, that's the hard one, and so then I added another one. So I'm going to talk through this first before I go to the calculator because you actually have to do a couple of steps before you get to put it into the calculator. All right? So first, you need to realize, and again, I'm going to tell you, write down the formula every time you use it. That way you'll have it memorized by the time you get to the test. All right? Your formula is going to be you used to only have to press in one place to edit. Now you have to press in 3. Write down your formula. So here is I. I is 1001 if you have a 2 by 2. I minus A is 1002 minus A. You can do this in your head, or you should be able to. 1 minus 0.6 is 0.4. 0 minus 0.2 is negative 0.2. 0 minus 0.2 is negative 0.2. 1 minus 0.4 is 0.6. That gives you the I minus A matrix, so this goes right here. All right? Your products and machinery is right here. Your solution matrix is right there. So the matrix you're going to enter into your calculator is this matrix. So here's what goes into your calculator. After you subtract I minus A, this is the matrix that goes into your calculator. All right, so now I'm going to jump to my calculator. And I actually have this as matrix B. Okay? So this is matrix B. All right, so now I'm going to go back into matrix and do math, ref, matrix B, close parentheses, enter. And what I got was this answer. Again, if you write a complete sentence, you get bonus points. You get 1 point bonus. All right, now if I go and do the next one. All right, so now let's jump back up to number 1. So, number 1. The sales department says the dealership charges 10% monthly cost to the service department. So sales to service is 0.1. Okay? And the service department charges 20% totally monthly cost to the sales department. So service to sales is 0.2. Okay? And then it's 0 sales to sales. So the sales department doesn't charge itself. Now, everybody's asked me, well, why would the sales department charge itself? Well, it could charge itself for, the sales department could charge itself for utensil, for supplies, for staples, for staplers, for trash cans, for, y'all getting the idea? The service department could charge itself for wrenches and do you get the idea? So it could charge itself for stuff. Okay? So you can't assume that those are always going to be in 0. Okay? You don't know what it could be. Okay? So set it up, sales to sales, service to service, and where they overlap. So service to sales is 10%, sales to service is 20%. Okay? Then you need to find I minus A. So you get 1 minus 0 is 1, 0 minus 2 is negative, 0 minus 1 is negative, and 1 minus 0 is 1. Okay? Then you have that the D, so the sales department makes this much, or costs this much, and the service department costs this much. So then what you're going to enter into your calculator, Ikes, is this, and what you get back, and this is number 1, or A. And so then we go back into second matrix, math, RF, and so this is what we had our answers. Okay? And that's what we got. Now let's go look at number 3. So, primitive economy, fishing industry, and oil industry. Unit fishing industry outputs 0.3. So we have fish to fish, fish to oil, oil to fish, and oil to oil. Okay? So fishing industry output requires 0.3 units. Fishing industry input is 0.35. Unit oil industry output, oil to fish, and oil to is 0.1. So input, output, okay, so it's output, buck. So this is fish to fish is 0.3. And fish to oil is 0.35. And then oil to fish is 0.4, and oil to oil is 0.1. Okay? So then I minus A is part A. Then if I calculate I minus A times fish, then I get our ref. So second matrix, that's this one. So I get that. Now, it says, and I round up. I don't know why I'm getting such big decimals. But I round up, and it could be that my decimal places are off. Do I get 1240? 1250. Fraction engineering, none. Okay. I was trying to see why I was not getting exact answers. Okay. 0.7, 0.04. Ha! Anybody notice the wrong answer there? Okay, so let's go back in to matrix edit 3. That should be negative 0.35. Okay. There we go. So make sure that you're getting the same answers here, okay? That will help you judge whether or not you're doing it correctly. All right, now I'm going to show you how to clear out your memory. And what you're going to have to do is do second memory, reset all memory, and hit, do you want to proceed? Yes. And that's the only way that I have found to clear out all the matrices. But when you do this, you then have to go back in and make sure that you turn your diagnostic back on. Because otherwise, if you have a regression question, it will not give you your R squared. Okay? So, as soon as you reset your memory and clear out your matrix, make sure you turn your diagnostic back on. So, second catalog, scroll down to diagnostic on and turn it back on. Okay? All right? If you have any questions, please email me. Thanks. Bye.